Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about another way to solve quadratic equations, and this is called the zero product property. So in our previous video we talked about the square root method. In this video we're going to talk about something called the zero product property. So go ahead and try to solve these first two equations using the square root method that we talked about in our last video. Maybe it'll work, maybe it won't. But take some time to look at them, and then we will discuss. Okay, so something we should notice right off the bat is that these equations look different than the ones from our previous lesson. Right? In our previous lesson, we had equations like x squared is equal to 15. We may have had x squared or 2x squared is equal to 18. Maybe x squared plus 12 is equal to 10. All of these have something in common that these two equations do not. And that is that they all have just an x squared. They do not have an x term. In these equations, we've got a term that's 3x here, and we've got a term that's negative 5x here, which makes these impossible to just use the square root method with. Let me rephrase that. In the way that you understand the square root method, it's impossible. There are very specific cases where you could still think about using the square root method, but for all intents and purposes, you can't. So we need to learn another method to solve quadratics when we have an x term as well as an x squared term. And we'll go through some of these examples throughout the lesson. The idea here, though, we cannot use the square root method when the equation has two variable terms with different exponents, right? So it has an x squared term and an x term. If they were both x squareds, well, then we could combine them and just have an x squared, but they're different. One has an exponent of 2, one has an exponent of 1. We instead will need to factor and then use the zero product property. I know you don't know what that is yet, but hopefully you know what factoring is, and factoring will be our first step. So let's go ahead and look at an example here. We're going to look at the one on the left. Now pause the video, see if you can factor the equation on the left, or at least the left-hand side. What does 3x squared plus 12x factor into? Think about what type of factoring method you need to use. Well, here we're going to use the GCF. GCF is 3x, the greatest common factor. Well, if I factor out a 3x from the first term, I'm just left with x. If I factor out a 3x from the second term, I'm just left with 4. So this is my new equation. Now here's where the zero product property comes in. Right? Product means multiplication. It means we're multiplying two or more things together. Well, I'm multiplying 3x, that's one term, by the term x plus 4. Right? And the reason I know I'm multiplying by that whole term is because the whole term is inside of parentheses. So my first factor is 3x. My second factor is x plus 4. Now, when I'm multiplying two things together, if either of them equals 0, the product's going to be equal to 0, right? Because any number times 0 is equal to 0. So if the green factor equaled 0, well, then my left-hand side would be 0. If the orange factor equaled 0, then my left-hand side would be 0. So if I can just figure out where each factor is equal to 0, and the way I'm going to do that is I'm going to set each factor equal to 0, that will allow me to solve the equation. For green, divide by 3. 0 divided by 3 is 0. One of our solutions is x equals 0. For the orange, subtract 4 from both sides. Our second solution is x is equal to negative 4. those are two solutions for this equation. And if you don't believe me, you can substitute them back into the original and see if the left-hand side is equal to 0. But hopefully the idea you want to focus on is, look, this green factor, if I substitute in 0 for x, I get 3 times 0, which is 0. If my green factor is equal to 0, it doesn't matter what my orange factor is. My orange factor could be 10, it could be 20. In this case, it's going to be 4, right, because 0 plus 4 is 4. But my factor could be any number, and my left-hand side would still be 0. Likewise, if I look at my orange factor here, if x is equal to negative 4, well, my orange factor is equal to 0. And then it doesn't matter what my green factor is, the left-hand side is still going to be 0. So if you can factor your equation into 2 or more factors, you can set both of those factors equal to 0 and just solve. Now, you do have to be careful. The equation does have to be equal to 0 to start off with. So right, we had a 0 on the right-hand side. If it's not equal to 0, well, the zero product property would not apply. Let's look at the one on the right. Again, pause the video if you haven't already and attempt to factor that. It's a different type of factoring than GCF. You can use a factor sum chart here. Okay, so I'm going to be looking for factors of 16 that sum to positive 10. Well, I've got 4 and 4. Those sum to 8, though. I've got 8 and 2. Well, those sum to 10. Those are the ones I must use. So I'm going to rewrite my equation. I'm going to have x plus 8 times the quantity x plus 2 is equal to 0. And voila, I have both of my factors. So I'm going to set them both equal to 0. X plus 8 is equal to 0, which means x is going to be equal to negative 8. I then have x plus 2 is equal to 0, which means I have x is equal to negative 2. So my two solutions here are x is equal to negative 8 and x is equal to negative 2. Let's check out a couple more. First, though, if you want to have this down somewhere in your paper, it's on the next page. Zero product property, this is what we discussed. If a times b equals 0, then either a equals 0 or b must equal 0. And again, this is just an example down here, kind of showing you if I have two factors, well, either one of those, a or b, we can set equal to 0. Let's look at, let me choose a couple. Let's look at number 5. Okay, pause the video. My hint to you before you start working on your own is that, again, you have to make sure the equation is set equal to 0 before you factor and use the zero product property. So this one's not set equal to 0. You need to make it set equal to 0 and then factor and use the zero product property. All right, so to set this equal to 0, I need to move the negative 8. Right? Well, to do that, I've got to add it to both sides. So that's going to give me x squared minus x minus 30 is equal to 0. Now I'm ready to use a factoring method. In this case, 3 terms, it's a trinomial. I'm going to use the factor sum chart. So I'm going to be looking for factors of negative 30 that sum to negative 1. Right? There's really a 1 in front of this negative x, or in between the negative sign and the x. Factors of negative 30, I need one positive, one negative. Oh, I could have negative 10, positive 3. That gives me negative 7. I could have negative 5, positive 6. That gives me positive 1. So what if I switch the signs? Well, negative 6, positive 5. That gives me negative 1. Those are the two factors I want to use. Rewrite your equation. x minus 6 times the quantity x plus 5. Then you have your two factors. So I'm going to have x minus 6 is equal to 0. And I'm going to have x plus 5 is equal to 0. I'm just going to solve both of these. And again, a lot of these are going to be very straightforward equations to solve, right? X minus 6, one step. I end up getting x is equal to 6. Add 6 to both sides. For green, I'm just going to subtract 5 from both sides. So I get x is equal to negative 5. Done. There are your two solutions to this equation. So a lot of the heavy work today is the factoring that we've done in previous units, right? The new part of today is the zero product property, setting those factors equal to 0 after you've done your factoring. But everything up until that was stuff that we've done before. Let's check out one more, then we'll call it a video. I do want to do one of the tougher ones, such as number 11. You'll notice that number 11, that equation is already set equal to 0, so we don't have to do any inverse operations there. But the regular factor sum chart here is not going to work, right? Because our a value is 10, not 1. So we got to use the AC method. Well, my 10 is my a, my negative 3 is my c, so a times c gives me 10 times negative 3, which gives me negative 30. So remember, that's going to be the number that I'm searching for factors of, negative 30. I still want them to add to my b term, right, which is negative 1. Well, it looks like we just did this one right up above. So our factors are going to be the same, negative 6, positive 5. Let's rewrite our equation. So I get 10p squared minus 6p plus 5p minus 3 equals 0. Let's make sure we have enough room. I got a factor by grouping. I don't have any factors yet, right? I just have a bunch of terms. So split them up using parentheses, factor by grouping. Factor of the first term, this orange, or this quantity, is 2p. So factor out the 2p. That leaves me with 5p minus 3. Good news is that there's no factoring to be done here. That factor is already prime, right? So there's nothing else to factor other than 1. So pull out the 1. 5p minus 3 is equal to 0. And then I can factor out of 5p minus 3 from both of these terms. So I'm going to get 5p minus 3. What's left is 2p from the orange, 1 from the green. So my other factor is 2p plus 1. Well, now I have my two factors, and I'm going to use the zero product property. 5p minus 3 is equal to 0. 2p plus 1 is equal to 0. These are just two steps, right? So in the blue one, I'm going to add 3 to both sides. I'm going to get 5p is equal to positive 3. I'm going to divide both sides by 5. I'm going to get p is equal to 3/5. Your answer can be a fraction. That's okay. In my brown, I'm going to subtract 1s from both sides, so 2p is equal to negative 1. Divide both sides by 2, I get p is equal to negative 1/2. And there are your two solutions. So you could end up having to use any of the factoring methods we've learned, right? Greatest common factor, factor sum chart, or the AC method. Once you've chosen the correct factor method, at the very end, we're always going to be using that zero product property. Okay, I think that's going to do it for this lesson. We've gone through all of the different types of factoring, got a little review there, and now we know how to implement the zero product property. So as always, have a good day, and I will look forward to seeing you next time where we learn about a third method for solving quadratic equations.